Hey everyone, let's all merge in between linked lists. You are given two linked lists, list 1 and list 2 of size n and m respectively. Remove list 1's nodes from the i's node to the b's node and put list 2 in their place. The blue edges and the nodes in the following figure indicate the result, right? So as you can see, we have removed all the nodes all the way to B starting from A, right? And we inserted this notice, right? And the new linked list is gonna be this one, right? The new linked list is gonna be the blue notice, right? So let's take the first example. As you can see in the first example, our starting position is gonna be 3, right? And our end position is gonna be 4. So we are going to remove all the nodes all the way to 4, starting from 3. As you can see, we are going to remove all these nodes and insert insert list 2, right? As you can see, list 2 is inserted between. We removed these nodes and we inserted then list 2, right? So as you if you noticed, like what we need to know is just the pointer of this node, and the pointer of this node, and the pointer of this node, right? We have to know the only thing we need to know is these three things, right? So how do we know like the pointer of this node? How do we know of that? So to know the first part of, let's say, let's call it the first part, or just let's say before, right? So we need to know, for example, if I have if a is 3, I need to know the pointer of the node before this node, right? The node in position 3. So to know that, like, I'm going to I can iterate all the way to the is position, right? Let's say it was if I let's say I start from here, and it's before is gonna be just none, right? When I'm here, the before is gonna be in this position, and when I'm here, the before is gonna be at this position, right? And when I'm here, the before is the before pointer is gonna point to this position, right? So once I once I'm here, I can just stop iterating, and now I have the pointer of the node before the is position, right? And to know the pointer of this position, what I'm going to do is I start from the first position. They say start from this position, right? They say start from this position and iterate all the way to this position, right? This position plus one, like we can iterate all the way to the base position plus one. And once we are at this position, for example, I have the pointer of this node, right? I have this pointer, let's say L, right? I have the pointer of this node. And to know the pointer of the tail of the second linked list, I can just iterate starting from the head of list 2 all the way to the tail, right? Let's call it T. Then once we know these 3 pointers, what we're going to do is just B dot next is gonna be just B dot, let's say B dot next is gonna be the head of list 2, right? It's gonna be list 2. L2, and the tail is of it tail dot next is gonna be just tail dot next is gonna be L, right? The last portion of the first linked list. So this is what we are going to do, right? This is how we are going to solve this problem, right? So the time complex is just the number of the the the, the time complex is just the n plus m, right? The size of the first linked list plus the size of the second linked list, and the space is gonna be also the size of the first linked list plus the size of the next linked list. So let's go to the implementation. So the first thing what we're going to do is we need to know the first part, right? Let's say the first part of the linked list, the pointer before, let's call it before, right? Before is initially pointing to none, right? So, and current is gonna start from the list one, since we're iterating to list one. And for I in range, let's say, let's iterate to all the way to A, the is position. Then before is gonna be current, pointing to current, the current position, and current is gonna be current dot next, right? Then once we have done this, we need to know the last, right? So let's call it last. Is just the last is gonna be, let's say we start from list one, right? And we iterate all the way to the b's position, right? Plus one. You know, so so last is gonna be just last root next, right? And once we know these two things, the next thing is we have to know the tail, right? The tail of list two. So it was list one initially, the head of the linked list, then list two, list two. Then, so while tail dot next, while if it's not the last node of the linked list, we make like the tail dot, the tail is just the tail dot next. Then once we know these three things, what we are going to do is we have to check the before, right? Before is none or not. We have to check this before. If before is not none, if it is the case, before dot next is gonna be list two, right? List two is gonna be this one. Then the tail dot next is gonna be the last part, right? And if 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 before is none, if before is none is just list one is gonna be just list two, right? List two. And also what we can just remove this one from here and make this one, right? So once we have done this, we can just return list one, right? List one is the one we are going to return. So the time complex is just, so this time is gonna be, time is the of m plus n, and space is gonna be the same as m plus n, right? So because, for example, for this one, we are going to iterate. The time is just we are going to iterate all the way to the tail of the second linked list, right? So it's gonna be the size of the second linked list, and B is going to be in the maximums, or the maximum position for B is gonna be n, right? So that's why we add the time complexity for this one. The size of this is gonna be the n, and the time complexity for this one is m. So we are going to add them, right? And the space is just since we insert list two to in list one, it's gonna be in, so in max. For example, at least for example, in the worst case, we may remove one node, right? So that's why the time complex is just the space is gonna be m plus n. So let's see if this works for the test cases. So as you can see, passed for the test cases given. So let's see if it works for all of them. So as you can see, it passed for all of them. So guys, if you like this video, please subscribe. It's gonna help me a lot.